to this resource, promotion, HECML.org. And if you go, yeah, computer's got a little problem with the space bar. I'm frozen.
Let it go.
Let it go. You go to HECML.org, and up here at the top where it says resources, if you click on that, so you'll see some links, especially right here. If you haven't downloaded Python yet, first step would be to download Python. Does anyone not have Python on their computer yet? Could someone that feels really good about helping them maybe help out those people and make sure they get downloaded?
I'm comfortable. You can do blindfolded, one arm, one leg.
So as long as you don't cut off my nose.
So, if y'all are downloading Python now, at one point it will give you an option to add Python to your environment variables to add it to your path. And it does say at the time like a warning, like this could cause problems. It's okay. If you go ahead and do that now, you won't have to do it manually. Basically what that'll allow you to do is when you're running programs from the command line, you won't have to navigate to Python before you run your program. Make your life a little easier. But if you have already downloaded Python and Python is not in your path, this link will explain how to add Python to your path. Is there an easy way to check if Python's in your path?
Open up command line.
Yeah, command line.
Yeah, if you type in Python your command line and it doesn't work, then it's not your path.
Okay. So if you guys could go to your command line, go to your command prompt and type in Python.
You
And
should be in the interpreter once it'll let you know you're in the right pathway.
if that doesn't work for you, could you raise your hand?
I don't know. I didn't hear what you were saying. Sorry.
I'm just checking if you have Python in your path.
Yeah. So here's.
All set.
How's it going?
On this side. All set on this side.
Okay. How are we doing over here? We're downloading Python.
So yeah, all of that.
What about you? Good? Okay.
She just typed in Python.
Hey guys. How's it going? Good? So we're just getting started. First step is went ahead and tell y'all to go to HECML.org, and then at the top of the page you'll see this resources button. It'll take you to this page. And then we have a few links you'll need for today, including these. If you don't have Python downloaded, first step is to download Python. When it gives you the option, you do want to add Python to your path or add it to your environmental variables. And if you already installed Python and you're not sure if it's in your path, you can just go to your command prompt, type Python. And if it gives you an error, then you need to add it to your path, and this will explain how to do that.
Which one?
To add the path. And if a couple people are having problems, we'll walk through how to add it to your path on here.
The text editor, open idle text, download. But if I already have idle,
You don't need it. Yeah, that's just if you don't have. Yeah, and if you don't have a text editor, I just added a text editor here. But any text editor will work. You can use anything.
You can use div, you can use your file is great. You just you can click the path, it'll make it live.
Thank you.
Hey, how's it going? Good. So all we've done so far is we're just showing you that HECML.org, we have a few files we're going to use today. If you already have Python installed on your computer, okay, then the first step would be to download Python. Okay, and there'll be a link here on this page. If you go to this HECML.org, then you'll see our resources in the white bar. You click on the resources, it'll be down here.
But it should be easier on
Data set on a
and then you know it's
Data set
hard,
is,
right?
uh,
Like, you want to put it in a account, in your account.
Hello guys.
Like in Linux, it's kind of. So everybody's on here.
All right, well, I guess we can start. Welcome to today's fourth general meeting for Houston Engineering Center Machine Learning. My name is Charles, and I'm here with Victoria today. We're going to talk about linear regression.
So we're going to start with linear regression because it's one of the simpler concepts to understand. But we can start here and build a simple basic model and build it piece by piece. And then in the coming weeks, we'll build from this. And we'll build up to more complex parts. But today we're going to learn the basic parts of an algorithm and how we implement it, basic steps of a project. How are we doing on installing Python and getting it in our path? I have thumbs up, thumbs down, thumbs in the middle,
Very good.
Thumbs up.
some thumbs up,
Shaky thumbs.
shaky thumbs. If you're ever having problems during the meeting or you're getting caught behind, if you could just raise your hand, and some people that are like really awesome coders will keep their eyes out and they might come and help you, or we'll direct them to you. Okay, so a little bit of background on linear regression. So we're going to focus on ordinary least squares today, which would be the simplest of the linear regression techniques. And we're going to do basic linear regression. So like one input, one output. The basic idea of linear regression is we're going to have some data. We're going to try to figure out how we can best model that data and minimize the error between our model and our data points, pretty simply. Since it takes data that could have a lot of different dimensions to it and just maps it in a two-dimensional way so that a one-dimensional or a two-dimensional line can go through it, it is a simple model and it's fast, but it also reduces the complexity of the data and you're not going to get as accurate of a model. And that's why this is a good starting place.
Okay, here's the theory for linear regression. Within the linear regression model, it's basically like how you see in like basic linear algebra, you have y equals mx plus b. Well, here we have y equals w naught plus w1 times x, where w naught represents the y-intercept, and w1 is the coefficient of the explanatory variable. And basically the explanatory variable is whatever x data point or value that you want for your data set that you want to monitor. It could be something that's such like length or a size of an object.
So this is the first time we brought out some math in a meeting. So it is linear regression, but do we have any questions so far or any comments on this? All right, we're math geniuses, we're fine. Okay. So the basic concept of linear regression, we're going to try to make a line. We're going to try to derive these coefficients for this line. We're going to try to derive our m and our b. Okay, so how can we do that? We're going to start with a data set. We're going to understand what our data set is talking about. We have to load our data set, take it from whatever format it's in, and put it in a format that our algorithm can work with, like a matrix. Then we're going to train our model using the algorithm on the data. Now we have a trained model. This model has been trained on some data. It's really good at looking at that data and predicting if A, then B. That's our training data. So now we need to take our model and test it on some new data and see how well it works on something it's never seen before. Once we start seeing how it's doing, we can go back and try to fine tune and add some more parameters to our model, maybe a little bit more than just the y equals mx plus b. Okay. All right. How are we doing? Do we have Python installed? Yeah? Okay. Okay. So you might have also seen back on that resources page at hecml.org, headbrain.csv. So we also need to download that file if we can. And when you download it, if you have a place where you like to keep your Python files, you can put it there. If you don't, I suggest maybe making a folder on your desktop, calling it Python, and downloading that file to that folder. Because you'll also want to run your Python script from the same folder. So it's nice just to have everything in one place.
Just opening as text, I think you have to copy it and paste it.
Oh yeah, so it will, when you go to it, let me see what it looks like. When it goes to it, you'll have to right click on the screen and say save as CSV. So if you go here, the screen just looks like this. So if you right click and then save as, okay, and then here I am gonna save it as a comma separated value. Very important that these values are separated by commas, because later we're going to be able to read the data file in the right way because it has those commas separating it. And we can save it wherever we want. I get some thumbs up when that's going good, or like thumbs up.
Some thumbs down.
Can you do it
Thumbs
one more
down.
time?
Can you do the same thing on the Mac?
Oh.
Can you save them the same way?
Yeah, I think it should be the same on a Mac.
Okay.
Yeah.
You do it
I guess
again.
that's what CSV is.
Yeah, so when you get to, you click on it, it should take you to this screen. So from here, you should be able to right click and save as. And even though it just looks like a raw file, it actually is already formatted as a CSV. So now you should be able to change the name if you want to, but it'll save as a CSV file and wherever.
And copy everything and paste it in.
You shouldn't have to copy and paste it.
It doesn't have, it doesn't have a problem.
Oh,
Sitting right there.
okay. So it looks like if you, in Microsoft Edge, it's just a text file, so
You can see I get everywhere.
you might have to use it on the browser.
Go look for it online,
For which one?
the headbrain code.
Yeah, and we'll have it linked up on the website as well. And I can also link you to the GitHub of the guy that, Movers, I think his name is, also sort of made the bones of this script.
So just go on either.
But if you're looking for it right now, you
Yeah.
go to hecml.org, and then under the resources tab.
I downloaded Python and then,
Great.
so what's in my,
Yeah, but you need to get these.
Yeah, so now you've got Python. Next step would be to get the data.
sorry.
So if you go to hecml.org, and then I'll show you really quick. How's it going, Ezekiel? Good? How you doing, T?
So you have that. So,
Okay. So yeah, so now we'll do this one, the data set for today. We have to bring that to your screen. And we can say that.
Yes. I got the cut.
You might either save it to a folder on your desktop somewhere, it's kind of easy to navigate.
That was just one important.
So if you go here, maybe you can make a new folder on your desktop, which is called Python.
So it's probably safe to like that folder you're
So now we'll put it on your desktop. Cool. So once you've got your data set, everyone doing okay? Got it downloaded? Anyone having problems? Okay. So now we're going to start writing our Python script. So we said the first step of our script, well, first we want to understand our data set. What are we looking at? So this headbrain CSV, it's comparing gender, age, head size, and brain weight. We're actually not going to pay attention to the first two features. We're just going to use the last two. So we're going to take head size as our independent variable. We're going to try to predict brain weight based on head size. So yeah, in cubic centimeters and in grams. Okay. So the first step is once we know what kind of data we're working with, we need to take our data, go from a CSV, load it into a matrix, we said, right? So back on the post over here, we actually have the full script that you could. Oh, I didn't put the full script. Never mind. I just put the paste of the script. So we're going to grab some of the script one bit at a time, and we're going to try to run it. So if you'll open whatever text editor you want to use, and if you don't have a text editor, now would be the time to maybe download that one that's listed here. It's just idle, but you can use any text editor. So we want to open up a text editor. Actually, use idle. Yeah. So, and then we need to open up a new script or a new file. So I'm going to open up a new file. Okay.
Open up Python.
Okay.
It's cool if I use Word.
You don't have any problems with it? Okay, so the first step will be to, we're going to grab everything from the first bolded title to the next bolded title. Copy it, put it in our new file, paste it, okay? This will be where we start. This is what we're looking at right now. So this is the first section that we've got. What we're going to do is this from sklearn linear model import linear regression. We're going to use sklearn's a piece of their library. We're going to use a tool they have called linear regression. We're also going to grab from their metrics. Metrics is like a scoring library, mean squared error. Once we've grabbed everything we need, we're going to also grab numpy as numpy. And Charles, what's the difference between from and import as?
The difference between from and import as is that from, it takes the actual module that you want, and then you can get classes or functions from that module under it. As you can see, import linear regression. For import, it just imports the entire library. So when we say import numpy as np, it imports all of numpy as its tagline np.
So now we're going to have all of numpy as at our disposal, all of pandas and all of matplotlib. And we talked a little bit about these guys at the last meeting. So numpy is going to have a lot of calculation, a lot of matrix and array techniques. Pandas as well has more advanced data frames and more data manipulation techniques, and matplotlib is just for displaying plotting. The power of matplotlib. Okay. Hey, how's it going? Oh, hi.
Yeah.
How are you? Do you have a laptop with you?
Yeah.
If you want to follow along, Angel can help you. Angel's sitting right next to you, and he can help you get to where we're going. So once we've imported these, now we're going to read the data. Reading the data means starting with the CSV that we downloaded.
The file name, yes. We read from the file all of the columns, and so that becomes a variable data. And then we print data.shape, and then we access the function data.head.
So what we want to do here is, it's nice that this is pandas, right? Pandas has made this super easy for us. We don't have to go through and figure out how to turn our CSV file into a matrix. It's going to do it for us. All we have to do is use this read function, tell it, hey, grab that CSV, put it in this matrix, call it data. So now we have, well, I guess this is a data frame since it's pandas. Now we have a data frame called data that contains all of our information. We want to make sure that this worked properly and get an idea of what we're dealing with. So we're going to print out data.shape. Data.shape, this dot shape grabs the shape of this matrix and prints it out, so in rows by columns. So we saw a lot of rows, a couple thousand rows and 4 columns, right? So if it all went properly, that's what we should see. And we also want to just go ahead and check the first couple of lines to make sure it looks okay. So data.head will print the first couple of lines, the first couple of rows of our matrix. So if you have this bit of code in your file, you should be able to now save it. So you can save this. I'm using this GUI. I'm going to save it in the same folder that I have my file in. Okay, so I'm going to call this headbraintest.py, and we do need to name it py. Right? So we're just saving what we already have and choose a name for it. Save it in the same folder as our data. Any issues here?
I need some help. So I'm trying to keep up here.
Everybody else doing okay?
Reasonable or not. I'll let you drop it. I should try to do
I guess so.
here. Yeah, with Anaconda. For the apple.
So what you can do is
Save it as.
so you can do file save as, and then you can name it whatever you want. Yeah, go on. You're great. Anyone else having any issues? Anyone got it? Thumbs up, got it? They got their file saved, ready to go? You got one? All right. 2. She's got the download going on. Yeah. Okay. Yeah. Okay, so once we get that saved, we have our data ready to go. So what should happen? If we run this code, we should see some output, right? Because not only is a matrix being loaded, but we went ahead and told Python, please tell us the size and the shape of this matrix, and please print out the first couple of rows. If you want to go to your command prompt, you can navigate to wherever you have, I have Python, I'm in the Python interpreter. If you're in the Python interpreter, you do want to exit that. We're going to run this as a file script. I need to go to the folder where I have my Python script saved. You can use that using your change directory command, cd, and then you can type the path of your file. If you're not sure where your file is located, you can go back and find it. Like you can go navigate through your windows and wherever you saved it. So right here, I see it in here, and I'm looking up here to see the path. So for me, it would be desktop Python examples. So I'm going to type cd for change directory, and I'm going to go to desktop Python examples. And now I'm in the folder where my script and my data are. How's it going? Oh, so that's the path for my folder that I typed. So for you, where is your file?
.txt. We want to get rid of that.
So it looks like it's in desktop Python code 1. So what you'll type is change directory, cd,
So then name it what you want and then save it as.
And space and then desktop.
So,
And then this slash. No space slash, then Python, and then code.
So once you save this.
Or first we just go to Python. And
This code is
slash
for
goes
Python, right?
Stuff like that.
Yeah, change the file.
Most scripts.
Okay, so you're there.
How's it going over here?
Let's file save as.
Sorry. So, what's next?
And then maybe go to the and that's where you want to save the CSV file.
Now we're back.
okay.
So we're just. So like.
Yeah, Marty just like
Python, sheet,
UI, the RTF.
Python.
They know what it is.
And then just write whatever file.
It's really just like sort of
Oh, okay, sweet.
Yeah, so what you should test?
Yeah, you start typing and push tab usually. As long as it'll start with push tab because it's like kind of find what you're talking about. And so you have to say.
Is it already installed?
So you're just gonna what that allows you to do after it's done, you'd like still bring yeah, it's just doing kind of things.
So now, the troubleshoot.
Yeah, it's ready.
Had a run and succeeded with that list.
I believe so, yeah, it's the last, exactly, yeah. The way that it is going to show you like the first 5 lines. So I assume that you know what, I got the same area. Figured it out.
Oh, definitely Anaconda.
Yeah, that's probably one.
You're right.
Let's see. Here's the CSV file. Okay.
Yeah, it is right there.
You know what? Our
Right, but Panda has its own. I mean, not Panda, but Anaconda has its
For you, I guess.
So you have to like check the box, otherwise like
You sure you want to
Do you know if 3.6 comes with pandas and
Yeah, that's why I have issues too.
Guys, so sorry. So we linked you just to 3.6, but then we're using libraries that you haven't
are
necessarily.
not present within.
Yeah.
I was gonna ask that.
Yeah. Yeah. So.
Right.
Everybody.
So that's where we are right now. So if you don't already have those libraries, you will have to add them. You can also use the Anaconda download. It gives you a lot of libraries with it. We will fix this link and add those libraries so that you can run this later. I'm so sorry for leading you guys astray.
I would say if you want to save yourself a lot of headache,
Yeah.
do the Anaconda way.
Do the Anaconda, yeah.
It's just, it gets like, especially once you get deep into it, you know, if you're trying to find like this library and this, and what you're going to do is you're going to download one library and it's going to have 6 dependencies to 3 other libraries and like 3 hours later, and then you're going to hate Python never use it again.
So guys, we are definitely going to change the download to an Anaconda download link. Awesome. Thank you, Ron.
I close out.
Lessons on the fly.
So
Yeah.
to change your directory.
So if you already had Anaconda or you already have these libraries, you can keep following along through with us. And if not, we'll link the Anaconda download, or you can type right now Anaconda.
And it's, if you just Google like Apple or
Anaconda download, not Nicki Minaj.
After me. Sorry.
No.
Yeah.
So,
And the other thing I'll say is like there's tons of these things to manipulate kind of like what they call bash scripting. Just like the bash. And so
okay, so you can just Google download Anaconda, and we'll link this in. But then you can just use this download Anaconda. It's very straightforward. It's click a button, and it'll give you everything you need. Yeah. If you do have Anaconda or you have the libraries, we're gonna keep going for now and just show y'all what it would look like. That way, when you're working with it later, you'll know what to expect. So what we did is we saved the first part of our file, went to our command window, navigated to the folder where the file is saved and where the data is saved. And now we should be able to type Python, tell us this is a Python script, and then the name of our file. And so I think I named mine headbrain. Okay. So if it works correctly, it should load all the data in, and we should get an output. So we did get the shape of the data. It looks like we have 237 rows and 4 columns. What I don't see is the first 5 rows. And so that's interesting that didn't come through. Data.head. Oh, it's because I don't have a print. So there's a good, what kind of error is that?
So that is a logic error.
That would be a logic error. Cool. So it looks like we need to add a print to the data.head. And then if I resave and try that again.
It gave me something, but it grabbed the first line and it said there's an issue with it.
Okay, so now it was able to figure out the shape, and we can also see the first couple of rows. It's nice that it does include the headers here, so we can keep an eye on what we're actually working with. And it looks like it uploaded.
Idle window.
Sorry?
Can you show the idle window?
Yeah. This?
Yeah.
Yeah. Oh, I just added print in front of the data.shape, and I put data.shape as the argument.
Yeah, I did too. So let's try that again. We'll just change it.
45 minutes, what happened?
I don't know, it's HIC connection.
Okay.
I think I wrote down and I find it.
Anyone able to successfully run the first part? No? Because we need the libraries. Anybody have the libraries and still trying it? All right, so we're just demonstrating now. So we will get everyone set up with the right libraries later, but for now I'm just going to show y'all what each part looks like. This is also how I'd recommend attacking an algorithm when you're building it from scratch. So don't go ahead and try to like make the whole thing and then it doesn't work and you're like, I don't know where to start. Start piece by piece. So first step is get your data loaded. If you can get your data loaded and you can see that it worked correctly, that you've got it loaded, that's step 1. Okay. Once we've done step 1, we've gotten our tools and our data. If we're using something like scikit-learn, we talked a bit about scikit-learn last week, about how it's great about making some common machine learning implementation that's really simple. So with scikit-learn, the next step is like the rest of everything. What we're going to do is we're going to we're going to say, hey, from the matrix data, grab the column called head size. Take the values and store them, and we'll call this X. From the brain weight column, take the values, we'll call that Y. We're going to figure out how many values are in X. And don't worry about this too much right now. Sometimes you do have to do some matrix manipulations to get things to work correctly. I think Charles said
Right, so sometimes you'll get a matrix and you have to reshape it so that like you can actually work with the data set. You might start off with a 2x3 matrix and you need a 3x2 on the type of application that you're trying to do. So that's why that function is there. It says cannot use rank 1 matrix in scikit-learn because a rank 1 matrix is a 1x1, which wouldn't fit your data appropriately.
And we'll get more and more into the specifics of matrices in the coming weeks. So we have our X and our Y. We have our X as our head size values. We have our Y as our brainwave values. We have our matrix shaped properly. So now we're going to go ahead and make the model. Making our model is one line. Our model is equal to linear regression, okay? Now we need to train the model. So this just creates whatever scikit-learn has made with linear regression, whatever they've done black box magic, we're going to train it with our data, which is, again, a one-line operation. We just fit it with X and Y that we made up top.
Yeah.
So now the model is created, the model is trained, 2 lines. So we're done. Now we want to see what happens. If we start with our head size and we try to predict our brain size, what will we get? So we're going to take, this is the, this REG is the trained model. We're going to tell that model, go ahead and try to predict the training values, the training head size values, and see what brain weight values it guesses. Then we're going to try and see, okay, how close was our prediction to the actual value? Because this is our training data. We know the actual value. So we're going to make some predictions on our training data, and then we're going to see how close those predictions are to the actual values. And we're going to measure a couple of error measurements. Evaluate it. So if we copy all of that,
Just put it back in the one the other side.
Just control these.
my interface is a little like glitchy.
What I have.
You talk to me, you can do a lot.
This is a laptop Amir gave me.
I know, that's what I'm saying.
Ah.
Exactly what
I can't
Tony
write the whole name for it or something.
Come on, there we go.
Oh.
Oh no! Okay, you know what? Simple solution.
That's how they changed everything to solid state drive.
Okay, so I'm just going to copy from the complete program here.
Griggs? Andrew.
Okay, so we're going to copy in the scikit-learn algorithm, which includes going ahead and evaluating it. And so we should see.
The apostrophes, I think, need to be changed. Because it wasn't running and then I changed it. Started with it.
Oh, okay, what apostrophes?
The apostrophes for the name.
Yeah, for like X, Y. Oh, I think it works for you. Wasn't working for me.
Okay, I'll have to look at that and see. So we'll go ahead and save adding in our scikit-learn algorithm and test. Go back. So we'll run the same program again with that added in. Python head brain test. Okay, so now we should see, again, it's going to tell us the shape. It's going to give us the head of the data. And it's actually done its prediction and its test. The only output we've told it to give us are these 2 scores. So this is our root mean square error, and this is our R-squared error.
Correct. Yeah.
So a perfect score would be 100 here. And
Yeah.
we're a solid D student right now. I think we can all feel for this root mean square error. And our R-squared is 0.6. So both of these values, what you could get from this is, hey, like, this regression is working. It's working okay. I'm ready to move on to the next step. If you're getting better than about 50%, that means that you're done with the really rough rough examination of the data, your model is roughly training correctly, and now you can start working on tuning. Because the tuning and correcting for some of the major errors inherent in any model will get that accuracy up a lot. So once you're at this point, we could actually start moving forward and addressing some of the finer details of our model. Like I said, we're not going to do that today. We just wanted to give you a main overview of what it looks like to start working with an algorithm and some data. But this is not a very exciting output, so let's look at another way that we can do this. So we said the scikit-learn way was very simple, right? Just a couple of lines. But what if we did it without scikit-learn? So if we do it without scikit-learn, we actually do this almost kind of manually using NumPy. So NumPy, is actually able to do this sort of algebraically. We can get the mean of x and y, and I won't, okay, so here's some math if y'all are really interested in how linear regression works. This concept is like 300 years old, and we're just turning it into code. So this is like manually calculating the regression, and we actually calculate our values. So we find our m, we find our slope, and we find our y-intercept, our b. So now we're actually getting the y equals, right here, we're going to plug those values in, y equals mx plus b. And we can come back to this if y'all are interested in some more math next time. But basically, we're able to numerically get our line, y equals mx plus b. And then let's use the matplotlib that we imported earlier. And we're just going to go ahead and plot our line, our prediction line, y equals mx plus b. We're also going to plot our original data and see how well our line
goes through the original data, the regression line, yes.
So let's run the full program. Okay. So first we should have the same output, the head and the first couple of lines, and we also have our data as a scatter plot. And so this is head size and brain weight. And then we have our lovely linear regression. So it looks like it's done a pretty good job of shooting right through the middle of the data. And like Charles was explaining earlier, what we're minimizing here is we're minimizing, if you imagine a line from every point going to this line.
The regression line. Yep. The vertical lines from the regression line to each point that you see on the graph are your error. So we're trying to minimize the error that is created.
So what we're talking about here is this. So yeah, these are our residuals.
Or offsets.
Offsets. And that's how far off our prediction. So for this head size, our prediction would be like 1.2. But the data point that we have is for 2. So the difference between that squared, that's the error for that point. We're going to sum all those up, and we're going to try to minimize that. And that's how we find the line that best fits all of the data. So this would be a rough measurement of error. Like I said, we saw that we're above 0.5, we're above 50%, so we're ready to do some more fine-tuning. For today, we've found data, we've loaded it into a matrix, we've run an algorithm, we've seen how well it works on our training data. We have not tested it on test data. So the next step here would be to go back and instead of training our model on all of our data, set aside some data so we can test it. Also, once we get to here, once we get our 0.6 R-squared value, how do we start tuning and correcting for some errors maybe inherent in this algorithm, maybe inherent in this model, or maybe just present due to our specific situation? So we're not going to go into that today. That'll be something we'll do next week. But if we're going to send out a homework assignment later that has some of this information, everything we've talked about, and encourage you guys to take it further. You could use this function if you want to get into train and test, get into that idea that we need to keep some piece of our data separate so that we can test our model on it, some piece of data that the model never trained on. We're also going to investigate overfitting and regularization techniques Very important for linear regression. And we'll talk more, come back to this next week. How are you guys feeling about all that? I got different faces going on right now.
I think we need to focus on getting everybody Anaconda so they can do the homework, because if not,
Right. We'll have to